Hi guys, this is the last week geometry, and today we're gonna learn about three-dimensional figures. So for today, we're gonna cover what is a three-dimensional figure, types of three-dimensional figures, characteristic of each three-dimensional figure, and lastly, we're gonna have some Jeopardy. So what is a three-dimensional figure? So in geometry, a three-dimensional shape can be defined as a solid figure or an object or shape that has three dimensions: the length, the width, and the height. Next slide, please. So these are a few types of three-dimensional figures. You have the cone, you have the cylinder, you have the rectangular prism, you have the cube, the sphere, and lastly, the pyramid. So let's start with pyramid. This is a regular type of pyramid. So a pyramid is a three-dimensional shape which has a polygon for its base and diagonal faces meet at one vertex. The surface area of a pyramid is 1/2 times S, which is the slanted height, the times 4b, which is the base, plus b squared. The lateral area is like kind of similar to surface area, but you don't count the top or the bottom. So like in this case, you don't count the square on the bottom of the pyramid. So the formula is just 1/2 times S times 4b. The volume of a pyramid is 1/3 times b, the base, squared times the height. And again, S is the slanted height, B is the base, and H is the height. The pyramid has 5 vertices and has 5 surfaces. So let's do a practice question. Given the square pyramid on the right, solve for the lateral area, the surface area, and its volume. So we know that the formula for the lateral area is times 4b. So let's just find all the values and plug them into the equation. This will be 1/2 times S. This is the slanted height, which is 16.4 times 4 times the base is 20. You plug it into your calculator and you solve. And you'll get 656. That will be the lateral area. Now let's solve for the surface area. The formula for the surface area is 1/2 times S times 4b times b squared. Again, we're going to find all the values and plug it into the formula. S will be 16.4, b will be 20 times 16.4 times 420 times 20 squared, and you'll get 262,400. Now lastly, let's solve for the volume. The volume of a pyramid is 1/3 times base times height. So the base will be 20 times 20, because this is a square base, which will give you 20 squared, and then you times it by the height. Not the slanted height, it has to be the height, which is 13. So the volume is going to be 1,733.3. Next slide. Now we're going to talk about cylinders. So a cylinder is a solid geometric shape that always has two ends lying parallel to each other and connected by a single side with a circular cross-section. The surface area is 2 pi r squared plus 2 pi r times the height. The lateral area doesn't count the two circles on the top or bottom. It doesn't count the two circles on the top or bottom. So it's just 2 pi r times the height. And the volume is pi r squared times the height. R stands for the radius, H stands for the height, and the cylinder has 0 vertices and it has 3 surfaces. So a cylinder tank has a height of 5 feet and a radius of 2 feet. If it were to be painted except the bottom of the cylinder, what is the area that needs to be painted? So we have to solve for the surface area, but then we have to remember that we're not gonna paint the bottom, so we have to leave out one of the area of the circle. So the formula for the surface area is 2 pi r squared times 2 pi r times height. Since we're only gonna paint one of the circles, we're gonna take out the 2 over here, and then we're gonna use this formula. Now let's plug in all the values we know and solve for the area that needs to be painted. R is 2 squared times 2 pi times 2 times 5. And you'll get 789.57 feet squared cubed. No, it's squared because this is surface area. Next slide, please. And now we're going to talk about the cone. A cone is a three-dimensional geometric shape that tapers smoothly from a flat base to a point called apex or vertex. Surface area of a cone is pi r s plus pi r squared. Lateral area is pi r s. Volume is 1/3 times pi r squared times the height. The r stands for the radius, the h stands for the height, and in a cone there's one vertex and it has 2 surfaces. The lateral area of a right circular cone is equal to 120 pi centimeters squared. If the base of the cone has a diameter of 24 centimeters, what is the length of the slanted height in centimeters? Okay, so let's draw the cone first. So it has a diameter of 24 centimeters, which means it has a radius of 12 centimeters because the diameter is like the 2 times the radius. And now we have so this time we are given the lateral area. It's 120 pi centimeters squared, and then our original formula is pi rs. We know that the radius is 12, so let's plug that in. And we need to find the slanted height. So now we could just solve. We could get rid of cancel out the pi on both sides. 120 equals 12 times s, divide 12 on both sides, and you get 10 equal to 5, which is, 10 equal to s, which is the slanted height.
Okay, so now we have sphere. A sphere is a geometrical object in three-dimensional space that is the surface of a ball. The surface area for formula is 4 pi r squared, and the volume formula would be 4 over 3 pi r cubed. And in this case, r equals the radius, and it does not have any vertices, and it only has one surface area. So in this case, we're asked, a sphere has a diameter of 18 meters. Find the volume of the sphere in cubic meters in terms of pi. So we know that the diameter equals 18. So we know that r equals 9. And the volume formula is 4 over 3 pi r cubed. And we would plug in the r, which is 9 cubed. Then it becomes 4 over 3 times pi times 729. Then equals 972 pi cubic meter. Because it says in terms of pi, so we're going to keep the pi, and the answer is 972 pi cubic meters. Next, we have cube. Cube is a geometric shape with 6 square faces, and so all the faces are square for cube, and the surface area is 6 times s squared, and the lateral area would be 5 times s squared, and the volume is s cubed. And in this case, s equals the side, so it would be this, and this. So all of them are the same. So all the sides in the cube is equal to each other. And so the width equals the length equals the height, and it has 8 vertices, and it has 6 surfaces. Okay, so it's asking what's the volume of the water can be held in this cube, and what is the lateral area of this cube. So the volume, so it's asking the volume of water can be held, so it's basically asking the volume of this cube, and we know that it's the formula for volume of cube is s cubed, so it would be 8 cubed, and it equals to 512 centimeter cubed. Then we have lateral area. The formula would be 5s squared, so it would be 5 times 8 squared. So it would be 5 times 64, which would be 320. 320 centimeter squared. And next we have rectangular prism. Okay. A rectangular prism is a prism which has 6 faces that are rectangles and all angles are right angles. So in this case, the faces are different from each other. One special case is that if the height and the length they are the same, then this side would be a square, and this side they would be the same. That's a special case. And the surface area would be 2 length times base plus 2 width times base plus 2 length times width. And the volume would be base times length times width, and it has 8 vertices and 6 surfaces. So the practice question asks for find the volume in cubic centimeters and the surface area in square centimeters of the rectangular prism. Okay, so we're going to solve for the surface area, which is 2 length times width plus 2 base times width plus 2 length times base. When we plug in the value, it would be 2 times 2 times 4 plus 2 times 5 times 4 plus 2 times 2 times 5 equals to 16 plus 40 plus 20, which equals to 76 centimeters squared for surface area. And for the volume, the formula is L times base times width would be 2 times 4 times 5 is going to be 40 cubic centimeters. And next we have triangular prism. Triangular prism is a three-dimensional figure made of a triangular base, a translated copy, and 3 faces joining corresponding sides. So the bases are going to be triangles, and the sides are going to be rectangles. The surface area formula is base times height plus 2 times length at height plus L times base, length times base. The lateral area would be base times height plus 2 times length times at height. And the volume would be 1/2 times base times height. And it has 6 vertices and 5 surfaces. It's asking for, given a triangular prism, what is area to be covered if the base area is not counted and if the base area is counted. So it's basically asking for the lateral area and the surface area, and the formula for the lateral area would be base times height times plus 2 times length times slanted height. Okay. But then in this case, since we are not having same slanted height, this slanted height we have 4. This one we have 3. So we are not going to use the 2. We're just going to use we're just going to do oh wait, never mind. It's actually correct because this 4 is actually the height instead of the slant height. This one is actually slant height. Okay, so basically what we're going to do is slant. That means that we have to divide it by half, and okay, so it's going to be 12 times 4 plus, why did I write 5 here? It's supposed to be base. Oh wait, actually never mind. I was wrong. It's supposed to be an S, but I saw it as 5. So. Oh my god, why did I write 5 again? It's supposed to be S. Okay, S. That looks like 5, but it's okay. Okay, so 12 times 4 plus 2 times 5 times 12 equals 48 plus 120 equals 168. And for the surface area will be the same, except that it also has the base area. So the formula is B times H plus 2L times slanted height plus length times base. So it would be, so since we already know this equals 168, we just have to find out length times base, which is 12 times 5. So it'd be 168 plus 60 equals 228 centimeters squared. Okay, so now we have Jeopardy. Okay, so it's asking what is the name of this 3D shape, and this is a cube.
What is the name of this 3D shape? And this is a rectangular prism.
Is it a triangular prism?
Yeah, it's a triangular prism.
And what is the name of this 3D shape? It's a it's a rectangular prism. Yes,
That's a
square base. Oh, pyramid, my bad.
What is the shape of this 3D shape? That's a sphere.
Yes, that's a sphere. And what is the name of this 3D shape? It's a cylinder.
Well, these stack well. No, because like they're like the base are on like the edges, like the vertices. So like if you stack these up, it's gonna like fall down.
Yeah, because it will be unbalanced. Will these stack well? No, because the bases will be stacking on the apex or the vertex, which will be unbalanced.
Well, these stack well. Like if you are gonna stack them on like the surfaces, then it will stack well. If you're gonna like stack them like the circular areas, then it will not. So it
I think you said opposite. Like when they stack on the base, like the circular areas, they will stack well, and then if they stack on the rectangular base, like it will not stack well because they would roll.
Yeah.
The stack well, it will stack well because it has 6 faces, surface faces. So no matter how you stack them on the faces, as long as you're stacking them on the face, not the vertices, it will be good.
Well, these stack well no, because like a sphere has no surfaces, so like no matter where you like stack them together, they will just like roll off.
This is a triangular prism. Yeah.
This is a cube.
This will count as a sphere.
This is a cylinder.
This would be a rectangular prism.
How many vertices does this have? It have 0 because this like it doesn't have like a corner where where all the it's like all round.
Yeah,
That's why
because it doesn't have any vertices that like all the surfaces joins or anything, because it only has one surface, so it doesn't need any vertices. How many vertices does this have? It doesn't have any vertices because even though it has 3 surfaces, but then they all join on like a line, so it doesn't have any vertices, like a point.
How many vertices does this have? We could count them. So wait, let me annotate. So there's one over here, there's one over here, 3, 4, 5.
How many vertices does this have? I believe this has 6, but we can count together. So 1, 2, 3, 4, 5, 6. Okay, so we have proved that it has 6 vertices.
How many vertices does this have? This have 8, but let's like check to make sure. 1 here, 2, 3, 4, 5, 6, 7, 8.
How many surfaces does this have? It only has 1 because it's just the face of a ball. So it doesn't have any other surfaces it's joining. Wait. Yeah, it only has 1.
How many surfaces does this have? So there's a face here, in the back, over here. So it has like 5.
How many surfaces does a cylinder have? It has 3 because this top one, bottom one, and the one in the middle, which is all around the entire circle.
How many surfaces does this have? So there's like a triangle in the front here, in the back, so there's 2. Over here, it like behind it, 3, and in the front, 4, and the bottom, 5.
How many surfaces does this have? And it's a rectangle. No, it's a cube. So I believe that has 6. Bottom, top, side, front, and the back. So it has 6. And that's it for today. Thank you. It's the end of the geometry course.